you guys working on this lovely warm-up, I'm actually going to go over it. That way if you have any questions, you can ask me. We'll feel comfortable with that. Our very first question, as I was walking around, most of you had it correct and wonderful. And you showed your work, meaning you showed plugging in the numbers. Is that a 5?
Yes.
Lovely. 2 squared times negative 2 minus 1. And as I was walking around, a lot of you use parentheses to plug in that number. Because if you forget to use those parentheses, it looks like 5 times 2 squared minus 2 minus 1. But if you use the parentheses, you realize you're multiplying, right? According to my order of operations, what item should I do first here? Somebody raise your hand. Mason. Parentheses. Is there anything I can simplify inside the parentheses? So he's actually jumping straight to the second step, which is right. The exponent. Mason, what is negative 2 squared?
4.
Perfect. What's 2 squared?
4.
Look, they're the exact same thing when they're squared. Now we'll multiply. 3 times 2 times 4 is 24. 5 times 4 times negative 2 is negative 40 minus 1, which is negative 17. Any questions? You've actually seen this problem already. We did this as a problem last Friday on the whiteboard, in case you forgot. Okay? All right. So that one is something you've already taken a quiz on, but we're reviewing it again for the simple fact that you have a chapter test coming up. Now this is what we taught yesterday. And I made you all members of the I Hate Fractions Club, correct? Okay. So we're going to go through this as though we hate fractions and make it easy. Because we're going to get rid of all of the fractions. So first thing we need to do is to find a common denominator. Can somebody else raise your hand? Josh. 12, I agree. So I'm going to write 12 next to each of these. 12, 12, 12. Now, in case you forgot the way I multiply these, I take the 12, the common denominator, and I divide it by the bottom. 12 divided by 3 is 4. I multiply it by the top. 4 times 1 is 4. So I've got 4x. Let's do that again. 12 divided by 2 is 6 times 1. 12 divided by 12 is 1 times 11. Now it's a nice simple problem, isn't it? Now there's no adding fractions, there's no dividing fractions, there's no subtracting. See, look, all you have to do is be able to multiply numbers, right? So now I'm going to subtract 6, and I'm going to divide by 4. So I get x equals 5 over 4. So far, okay? But what must I do now? Check it. Yeah. So I'm going to plug that in. 1/3 times 5/4 plus 1/2 equals 11/12. Wait. Allie, do you remember how to multiply fractions for me? How would I multiply these two? Not cross multiply. You're close though. Go straight across. Okay? So 1 times 5. 3 times 4. Plus. Now in order to add fractions, you have to have a common denominator. So if this is a 2, my common denominator needs to be a 12. 6. So it'll be 6 over 12, right? Now, Caleb, is that true then? Is 5 12 plus 6 12, 11 12?
Yes.
Okay, there we go. If you use this method, you get rid of fractions from the beginning, and it's an easy problem to solve. What is another way I could have checked it? Especially on Friday when you take your quiz, you're allowed. What? Exactly, Allie. Calculator. And you'll get to use that. And tomorrow we'll actually practice with the calculator when we're reviewing. Any questions? No. All right, so turn to the beginning of your spiral notebook to your table of contents. And go ahead and write down and write down our objective on line 4. Then turn to page 4 and write down that objective again at the top. So we're going to work on rewriting equations with more than one variable, meaning we're going to solve an equation for a simple letter. Why would I ever want to solve this equation right here for y? I'm even going to go specifically for y. Why would I? Mason. That's it. That's perfectly it. And that's the reason I go over this. Next chapter, we're graphing. And I'm going to give you this type of an equation and then say graph it. Well, in order to graph it, it's easiest if I get it into y equals mx plus b form. Raise your hand if you have Mrs. Field. Or had. Oh, you don't have. All right. Perfect. Then put your hands down. If you've had her in the past, or if you have her, she actually makes you do this also. But maybe not with X and Y so much. Maybe with like F and T for Fahrenheit and Celsius. I know she does some other chemistry based problems where you have to solve for a variable. E equals mc squared maybe. Some basic problems where you're just solving for a variable. Nothing too rigorous. But here, that's what we're going to do. So the first thing I do, I check for fracture. Because that panics us, right? Fraction. Do you see any? No. Okay, good. So then I look for addition or subtraction. Do I have addition or subtraction? Yeah, I see subtraction right there. So I'm trying to solve this for y. So I need to move the 11x to the other side. How do I do that? I'm going to subtract it. So if I subtract 11x, I have left on this side negative 9y, and on the other side I have negative 11x minus 4. Now, I do purposely put the x part first and the number part second. Because like Mason said, eventually we're going to graph these. And I like my slope to be first and my y-intercept to be second. Somebody else raise your hand, tell me, how do I get rid of the negative 9? Divide it. I'm going to divide, and this is the key thing, everything by negative 9. Everything that's separated by an equal sign, an addition sign, or a subtraction sign. So I'm going to put a negative 9 here, here, and here. So I get y equals negative and a negative. Good. I'm actually going to write it 11/9 x, but it doesn't matter. If you wrote 11x over 9, that's perfectly fine too. That's 100% correct. All right. Hey, I'm going to stick with you there. Negative 4 and negative 9 make what, Madison? Perfect. And that's my answer. That's all there is to it. Raise your hand if you feel pretty good with that. All right, good. I would actually have to change it to a decimal. And 4/9 is probably close to 0.5. So I'm going to put it somewhere between 0 and 1. Okay? And that's where we like our y-intercepts to be whole numbers if possible, but we love our slopes to be fractions. Okay? Not mixed numbers. Bless you. Okay, so here's our next problem. Area equals 1/2 base times height. What's this the area of? Allie? Triangle. It's a triangle. So in case I ever have to solve for h in a triangle, I'm going to know how to do it. All right. Nate, in this problem, there's something in there that scares most students away. What is it? A fraction. But we're not scared because we're members of the I Hate Fraction Club, right? So, how do I get rid of a fraction? Multiply by the? Exactly. What's the common denominator here? 2. So I'm going to multiply both sides by 2. So I'm going to have 2a And on this side, the 2 and the 1/2 cancel, so I'm left with BH. Do not try to multiply the 2 by the 1/2, the B, and the H. Okay? When you multiply everything by 2, it's everything separated again by a plus sign, a minus sign, and an equal sign. Okay. So Nate got us to this part. Now there's no fractions. We're not panicky. We're actually doing pretty well. So I'm actually going to say, hey Carter, can you help me out here? I want to get H by itself, meaning I want to get rid of the B. How do I do that? Well, not subtract. I can only subtract if you see a plus sign. I can only add if you see a minus sign. So what could I do here then? What's happening between the B and the H, Carter? Exactly. What's the opposite? Exactly. So I'm going to divide by B. So I get H equals 2A over B. Now I'm actually glad you said about we can subtract it, because a lot of students think that. But unless you see a plus or a minus sign, you cannot add or subtract. Okay? And that's my answer to that problem. Feel pretty good? No? Where are you stuck? Do you understand our first step? Okay. And I'm just trying to get rid of the B, right? What's happening between the B and the H? So I use the opposite. Don't make it too complicated. Like you're thinking, this has got to be really hard, there's got to be a lot to it. It's nice, easy, and simple. Just multiplying and dividing.
Do you ever want to get rid of the H, not the B?
You may, if the problem says, solve for P.
Oh, it's just for H. Okay,
Exactly. Good question.
How does 2 cancel out to 1/2?
What's 2 times 1/2? 2 over 1 times 1 over 2.
2 1.
So, exactly. Okay, any other questions? All right. Let's do another one. P equals 2L plus 2W. What's this formula? Perimeter. It's actually perimeter of a rectangle or square. Or parallelogram. But I'm solving for W. All right. I'm going to go back to Nate. Nate, is there anything up there that scares us? Okay. All right, so there's no fractions. Good. Now, do you see addition or subtraction? I see addition. Good. So I need to use the opposite somewhere in here. Meaning I need to move the 2L to the other side. And in this case, I get to subtract 2L. I'm going to write it P minus 2L equals 2W. If you were thinking that you wanted to write negative 2L plus P, would that be okay? Yeah. I like the P first because it is positive. I don't have to write a negative sign first. First people I see in the morning, I like them to be positive. First thing I see in the equation, I like it to be positive. All right, so now I need to get that W by itself. Emily, how do I get rid of the 2? Good. And when she says divide it, she means divide everything by 2. Everything separated by an addition sign, subtraction sign, or equal sign. All right, so I've got P over 2 minus, here the 2's cancel, equals, W and W make, 2 over 2 makes 1, so I'm left with a W. Any questions? That's it. I got the letter by itself, I'm quite happy, right? Not too complicated, right? All right, let's make it complicated. Let's do a hard one here. Here's the hard one. Now, I'm going to give you a minute to actually work on it on your own. But before we do, I'm going to pick on Nate one more time. Nate, is there something there that scares almost every student? What is it? Oh no, there's fractions. What do I need to do, Nate, so that I can do this? Good. I need to multiply everything by a common denominator. So take a few minutes. I want you guys to go ahead and work on this together. All right, so I had you guys try this problem on your own, and I walked around to see how you did. And it's interesting, because you did very well. But depending on how you decided to actually do the problem. So I'm actually going to do it two different ways. To prove to you it can be done two different ways. So 2/3 x minus 1/2 y equals 12. All right. First type of person I saw was the person that could figure out least common denominator. Notice I said least there, although Nate did not say least whenever he was talking to me about common denominator, right? Well, the least common denominator is 6. If you did not use 6, please do not change your work. Okay? Because if you did not use 6, you used a common denominator of 12. So notice I'm going to do it two different ways here and prove no matter what denominator you use, as long as it's a common denominator, it will work. And that's why I like when Nate said find a common denominator. So here, 6 divided by 3 is 2, times 2 is 2x. 6 divided by 2 is 3, times 1 is 3. 6 times 12 is 72. If I do it over here, 12 divided by 3 is 4, times 2 is 8. 12 divided by 2 is 6, times 1 is 6. 12 times 12 is 144. Oh, thank you. Thank you. All right, so we're solving these for y. I'm going to subtract 4x from both sides. Thank you for fixing me. And over here, instead of subtracting 4x, I'm going to subtract 8x. So I get negative 6y equals negative 8x plus 144. I'm going to divide everything by negative 3 in this equation. So I get y equals negative 4 divided by negative 3 becomes positive. If you take 72 divided by 3, what number do you get? 24. So I'm going to write minus 24. Now, notice with using the least common denominator, my numbers were smaller, right? Doesn't necessarily mean that that's the only way to do it. Over here, I'm going to divide everything by negative 6. So I get y equals negative 8 over negative 6. Comes positive 8 over 6. If I divide them both by 2.
Positive 4 over 6.
Oh wait, so far it's looking the same here. Okay, I know I have a minus sign. And if I take 144 divided by 6, not 64, 24. Hey, I got the same thing, right? So it doesn't matter. If you decided to use 6, it works. If you decided to use 12, it works. All you need is a common denominator. In fact, you could have used the common denominator of 144 and it would work. But I don't want to have to try to multiply by 144, right? Okay. How do you feel with those? Pretty good? Let's do one more that I'm going to make up. Let's do x equals 3. Favorite letter? M. Favorite letter? Q. All right, we're going to solve for Q. We're going to take that lovely equation I made up, which honestly has no scientific reason of being here, but solve it for Q. Do I have fractions? No? Okay, so I'm not scared. Do I see addition or subtraction? No. So what I want to do is I want to separate the 3m from the cube. That's all I want to do. Well, what's happening between 3m and cube? Multiply. What's the opposite, Caleb? So I'm going to divide both sides by 3m. So Caleb, you just came up with my answer. X over 3m equals cube. That's it. Not too difficult, right? Feel pretty good with that one? Good. I purposely did that one, Madison, because your first essential work problem looks similar to it, except it has the letter pi in it. But don't be afraid. Don't change pi to a decimal. Leave it as a symbol. Kind of like m is a symbol. It's a letter, right? Pretend pi is the same thing. So your essential work for tonight, page 24, page 29, 24 to 29 all.